Good evening. Thanks so much for joining us for our Math Mania Monday with Strategic Intervention Solutions. My name is Shannon Samolsky. Hopefully you were able to join us last week for our first broadcast using the Rec and the abacus. We hopefully have fixed some of our technical difficulties, so you should be able to see nothing in reverse. Today what we're going to talk about is addition strategies. We're going to go through 3 different ways plus the traditional, and we'll kind of show you a unique way to use non-proportional means to solve addition problems. If you're new to us, our website is sis4teachers.org. On our website, you can register to get all of our different free information that we provide on our blog as well as our free resources. When you pop up onto the website, there's a pop-up screen that you can enter your email in. We encourage you to follow us on Facebook and share with your friends, which is at strategicinterventionsolutions.org. The other things we'll be talking about today are kind of going to be going through these different types of addition strategies. This will actually post in our blog with a free handout that goes along with this later this week. Today we're going to talk about strategies that are going to help you in the classroom. Our first strategy that we're going to talk about is decomposing and composing. Decomposing and composing is a great strategy for kids to use in the classroom because it helps them to break apart numbers and put them back together. We use a variety of different tools. If the sums are going to be lower than 20, we would use something similar to this, which is the Counting Buddy, which is a math manipulative that I designed that moves on a macrame beaded system. Another option is to use the Rec, which we talked about last week, or even using a double tens frame or 20s frame as an actual tool. So we're going to look at the problem first, 8 plus 5. 8 plus 5, we want kids to sort of see the structure. So if we were to show 8 using a linear tool, such as this, we're going to show 8, and we're going to ask them to add on 5 more. We want kids to be able to bond or decompose to find a friendlier number or an easier way other than adding 1 to 1. A lot of kids turn into a bunny and want to hop in math and count 1, 2, 3, 4. Sometimes they put the big number in their head and they count on. As children become more efficient, we would like for them to see that they can decompose a number and bond it with another number to sort of see where that connection is. So as our beads here have 8 on one side and 5 on the other, you can decompose the 5 into 2 and 3, bond the 2 with your 8 so that you end up with 10 plus 3. When we talk about math, we talk a lot about CPA, which is concrete, pictorial, abstract. This is obviously the concrete model that we might use for this, but if I was having a child show me, as they're doing this in a pictorial representation of their mathematical thinking, one might decompose that 5 into 2 and 3, and they're going to bond the 8 with the 2 to make 10. So their new problem is going to be 10 plus 3 equals 13. This is a great skill to be mastered during a child's first grade year as they start to bond and make a friendly 10. Of course, we know we can count 1 by 1, but as problems become more difficult for children, we'd like them to use number sense to show their different ways that they remember how to use it. If we had something like 18 plus 6, the sum of this is going to end up being higher than 20, so we'd want to change our tool to maybe using the abacus. And so we want to see if 18 plus 6, if we want to get to that next decade number, that would be to 20. And so we'd want children to be able to decompose the 6 and be able to give part of that to this number to make it an easier decade to promote mental math. So if we were to decompose this into 2 and 4, we would bond the 18 with the 2 to get 20, so our new problem becomes 20 plus 4, which is 24. I do have our really large abacus that I'll bring out just to kind of show you what that would look like. The beads are always clear to the right with red in the lead, and so if I were to show that 18, I would show the first add-in on the abacus on the top row. I'm going to go on to the next row and show the next add-in. Some children don't understand that there's only 2 more to be able to get to that next decade, and the abacus provides a really nice visual tool that's very systematic for children. And so we know that we need 2 more, so we're going to take our 6 and we're going to decompose it into 4 and 2. So we're going to take that 2 and we're going to bond it with our 18 to get that nice even 20 to get our answer of 24. The abacus can be used for lots of things, but decomposing and composing is a really great way for kids to be able to see how to use it. Again, The abacus could be used for this one as well, 27 plus 14. We know that we need 3 more to get to that side, leaving this side with 11. And so when we add our 27 plus our 3, we get our 30 plus the 11 to get our answer of 41. And so giving kids different ways of looking at this in a spiraling content can really help them as they start to expand on their knowledge with numbers. We want kids to use decomposing and composing all the way up through decimals and fractions when they're doing measurements of units. When a child might be in 4th or 5th grade, we might want them to add, fractions together that have maybe a common denominator. Instead of them adding across like you or I did, we would say 6 plus 3 is 9. We put the 9 at the bottom and the 7, and then we realized it was a fraction larger than 1, and they'd want me to put it into a mixed number. In this case, we're going to go ahead and make 7 sevens because that's going to get us the 1 whole. So I'm going to decompose 3 sevens into 1 seventh and 2 sevenths. We're going to bond the 1 seventh with the 6 sevenths to get 1 and 2 sevenths. And so we talk to kids about finding an easier way for computation. So this strategy has lots of different ways that you can use it. It's very changeable depending on the concept that you're teaching. But we like for kids to go ahead and categorize that they are using the strategy of decomposing and composing. The next strategy we're going to talk about is compensation. Compensation is another strategy that is similar, but it is using kind of a way that you might find something that you already know. And so if I were to look at this one, 25 to 26, we call this, if you give 1, then you get 1. So in addition compensation, if you take 1 off, you're going to put it back on. So for 25 plus 6, it's very similar to looking at 25 plus 25. So I'm going to just change the problem temporarily to something that's a little bit more friendly to me. And so in actuality, I actually took away 1. And so 25 plus 25, if I'm thinking of quarters, that's easy because it's 50. But technically, I took 1 off, so I have to give 1 back. So I'm going to take that 50 and add the 1 to get my total of 51. This same strategy can be used when numbers are really close. You use this a lot when you're out shopping or different things and you're kind of estimating prices of things. If I did 198 plus 57, this is really close to 200, so I'm going to go ahead and give that a 200 plus 57 because I can mentally add that together to 257. But I actually added 2 on, so I'm going to take that 2 back off in the end. So I'm going to do my 257 minus 2 to get me my 255 when I add that together. So this strategy, can you check it? This strategy is used for compensation to see that kids have another way or another strategy to change the numbers to make it for easier computation. Okay, our next strategy that we're going to talk about is partial sums. This one's one of my favorites. We use place value strips to help children to show the concrete of this concept. We're going to pull apart these numbers by place value. This is very similar to decomposing and composing. The only difference is when you're taking the numbers apart, you're actually pulling it apart through the place value. So if I have 23 plus 5, which you see in this number, children can actually take this and break apart the 20 and the 3 and then have their 5. And they can add these together and go ahead and get their 8 and put their 8 back with their number 20 to get 28. And so we kind of call these branching bonds. Branching bonds are a way that kids can kind of show their ways as they're decomposing as they get into higher problems. So to model that, I'm going to decompose my 23 by its place value, which is 20 and 3. I know this fact here is pretty easy because it's 5 and 8. 5 and 3 is 8. So I'm going to go ahead and put my 8 and add it to my 20 to get 28. Again, if I wanted to show this through larger numbers, even in the hundreds, you can decompose the numbers or split apart the numbers by the place value. So if I have 36 plus my 55, children might first want to pull out their 10s and add those together, or pull out their 1s and add those together and exchange those to figure out the answer. If I drew a pictorial representation, it would look like this. 30 and 6 plus 50 and 5. I'm going to put these two back together, so I'm going to compose the 50 and the 30 back together to get 80, And I'm going to add my 6 and my 5 to get the 11. And when I add that together, I get the total of 91. We would like to have kids use the place value strips. We have in our math salad bars and our project schools, this is the demo set of place value strips. We sell the individual class size on our website in our store, but it's really great if you have a class of about 30 kids to have every child have a set of the place value strips. It can be used for a variety of things that will feature in other Math Mania sessions. So far we've had decomposing and composing, we've had compensation, we've had partial sums. The last one we're going to do is the good old traditional method. In the traditional method, a lot of us use base 10 blocks, which is known as a proportional tool. A proportional tool is really great in children's understanding. One of the things that we add in, though, is a non-proportional manipulative. The non-proportional manipulative that we're going to use today is the place value discs. These discs we put in the math salad bar in a clear envelope that are labeled on the back, so they all end up getting back in the same bag. We usually have 1 to 4 students use these. These math are great. They were developed by one of my colleagues, Kristen Hilty, and they really fit the discs really great for kids to kind of see in the area of place value. So for the traditional method, it's not an ignored method. We still do the traditional method. We would like children to solve problems other ways so that we can be sure that they know all the ways and have a really great way for communicating their thinking. So for this one, we did 46 plus 25. So if you're not looking here at the bottom and just looking at the top, I went ahead and put 40 and 6. Down here, I added 20 and 5. And so we want children to be able to look at this. This is a dry erase mat, which is kind of nice. We'd like for them, again, similar to using that decomposing and composing strategy, we would like the children to be able to fill in those empty spots. So we're going to go ahead and decompose our number 5 into 4 and 1. So we're going to go ahead and put our tiles in here. Okay, so we look at those 6 ones and those 5 ones. We've renamed it 11 ones. Okay, and so we have 11 ones, but we'd like to rename 11 ones the same as 110 and 1 1. So we're going to take our ones and we're going to pull these off and rename the number 11 from 11 ones to 110 and 1 1. And so we're going to put the 1 at the top here. We have our 10 that we brought over. Showing that in our number model, 6 plus 5 is 11, which brings over 110 and 1 1. A lot of us carry it to the top, and we say we're carrying 1. We actually didn't carry 1, we carried 10. So we want children to be able to articulate their mathematical thinking in a way that makes a great understanding with place value. If I were to put together my 4 10s, my 2 10s, and my 1 10, I end up with 6 10s, so I end up with 61. All of these strategies are really great strategies to teach in your classroom. These 4 strategies we would like for children to be proficient in once they are in their 2nd grade year. We start children in kindergarten with decomposing and composing numbers. We would like children just to use that strategy all the way up through 5th grade and higher, but the other strategies come in throughout the development of different phases. And so this decomposing and composing is really great in 1st grade and up. A lot of our kids start to do compensation, similar to a strategy that's used as doubles plus 1, doubles minus 1, even in 1st grade. Partial sums we usually save for the latter part of 2nd grade to be introduced, and then it's done throughout. 2nd grade is when the traditional method is used. And so these are 3 ways, plus the traditional, that we encourage children to be able to solve problems in multiple different ways. So I hope this kind of helped to give you a little bit of a tutorial on how we solve addition. We're having a contest this evening with our Facebook Live video, so if you're still tuned in, you can be a part of our contest. From now until 8 p.m., if you tag 5 of your friends in the comment section of our video tonight, you'll be entered into a contest to win one of my publications, which is a strategy game CD using the 8 mathematical practices. We hope that you can join us next week. We're actually going to be in Palm Springs, California, presenting our Facebook Live video, and we're going to be doing a very similar presentation to this, but it's going to be all on subtraction strategies. These will also feature in our blog with the video again, so that you can use it and hopefully use these tips in your classroom. Thanks so much for joining us.